Hi, welcome back to the channel. Today we are going to see grade 10 CBSE important 1-mark questions. We saw 10 questions in the last video. We will see from 11 to 20 in this video. Okay, the 11th question. The volumes of the two spheres are in the ratio 24 is to 64 is to 27. Then ratio of their surface areas is. Okay, we all know the volume of the sphere. So what is that? Volume of the sphere equal to 4 by 3 pi r cube. Okay, we'll write now volume of the big sphere. So we will put a capital R for this. So it is 4 by 3 pi capital R cube. Volume of small sphere equal to 4 by 3 pi small r cube. Okay, we know it is the ratio. So which means the fraction. So volume of big sphere is to volume of small sphere. So we have to just substitute the values now. Four by 3 okay. We are substituting the given value of 64 is to 27, which is 64 by 27 okay. So we'll now substitute the volume of the big sphere 4 by 3 pi capital R cube by 4 by 3 pi small r cube. So we will cancel the common terms. On the RHS we write this is equal to 64 by 27. So cancelling out, capital R cube by small r cube equal to 64 by 27, which is capital R by small r is equal to cube root of 64 by 27. So cube root of 64 is 4. We can write 4 by 3. So we have capital R by small r equal to 4 by 3. Now, what is the question? We have to find the ratio of the surface area. So let's write the surface area formula. Surface area of big sphere equal to 4 pi capital R square and surface area of small sphere equal to 4 pi small r square. We have to find the ratio now. So we write 4 pi capital R square by 4 pi small r square. So cancelling out we get r square by r square. So which is capital R by small r the whole square. So we will now substitute the r by r formula from the previous step. 4 by 3, the whole square. So this is 16 by 9. The answer is 16. Sixteen is to 9. Okay. The 12th question is the quadratic polynomial with minus 81 as product of zeros and 3 as one of the zeros respectively. Then the polynomial is. Okay, let's assume the zeros to be alpha and beta. So alpha into beta equal to minus 81. They have given one of the zeros as 3. So we'll take alpha equal to 3. Okay, substituting the value of 3, we get beta as minus 81 by 3. So which is minus 27. Okay, now we know alpha and beta. So we have to write the polynomial. Let's write the standard form of the quadratic polynomial in terms of zeros. So that is x square minus inside the bracket alpha plus beta into x plus alpha beta equal to 0. Please remember the standard form. Okay, very important. Now let's substitute the alpha and beta values. X square minus 3 plus minus 27 into x plus equal to 0. X square minus, it becomes plus 24x minus 81. We can substitute alpha beta in the previous value, previous step itself. It is our wish. Okay, so this is the equation we needed. 13th question. Value of cosecant 30 plus cot 45 is dash. Okay, for this you have to know the values in the tabular column. Hope you all remember everything. So cosecant 30 is plus 45. Cosecant 30 is 2, cot 45 is 1. So 2 plus 1 equal to 3. So the answer is 3. Let's move on to the 14th question. 20th term from the last term of the AP. The AP is 3, 8, 13 is dash. Okay, since the question is we have to find 20th from the last term, we will reverse the AP. So now the AP is reversed. So that's how it is easy to find 20th term from the last. Okay, please note the question carefully. The AP given, so we are reversing the AP. So we are just writing it in the reverse order. Now the A is small a will be equal to 253 and D will be equal to 3 minus 8 which is minus 5. And N is 20 for us here. So what is the formula? AN equal to A plus N minus 1 into D. So we substitute the values we have with us, which is 253 plus 20 minus 1 into minus 5. which is equal to 253 into plus 19 into minus 5, which is equal to 253 minus 95. So do the subtraction and you will get the answer 158. Okay, so this is the required answer. Let's move on to the 15th question. If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then alpha plus beta equal to. So this is a direct question. So from the given equation, it is the standard form of the quadratic polynomial. So we know the relation alpha plus beta equal to minus b by a. Now the 16th question. The surface area of the given figure. This is in the shape of a cone and a hemisphere in the bottom. So what is the surface area of the cone? CSA of the hemisphere equal to 2 pi r square. And CSA of cone equal to pi RL. So adding together we get surface area to be equal to 2 pi r square plus pi RL. So we can take the common things outside, which is pi r. So inside the bracket it will be 2r plus L. So this is the answer. Okay. In this itself there is a OR question. So we will check the next OR part of the other question. Find the CSA of a right circular cone of height 15 cm and base diameter 16 cm. So what is given? Height and diameter. Let's draw the picture for this. It's a right circular cone and we will mark the given values. Diameter is 16 and the height is 15. We'll write what is given, so which is the height and the diameter. We have to find the slant height, which is L. So what is the formula? L square equal to R square plus H square. So substituting we get L square equal to 8 square plus 15 square, which is 64 plus 225 and which is 289. So L square is equal to 289. So L will be equal to square root of 289, which is 17. So some of the key numbers you have to know the square root, such like 17 square. So this is the L. Now we have to find the CSA. So you all know what is the formula? CSA of cone equal to pi into R into L. So we take 3.14 as pi because we don't have anything to cancel. So we just substitute the values and do the multiplication and get the answer, which is 427.12 centimeter square. Okay, this is the required answer. We'll move on to the 17th question. State whether the given statement is true or false. Justify. If the graph of a polynomial intersects the x-axis at only one point, it cannot be quadratic. Okay. The graph can intersect the x-axis at one point or 2 points or at no point at all. Still, it can be quadratic. So if it intersects at one point means it has 1, 0. So definitely intersecting at one point is a quadratic, and this statement is false. Okay, we'll move to the 18th question. If k square plus kx minus 3 equal to x minus 3 into x plus 1, then find the value of k. Okay, so we are just going to multiply the RHS now. We'll retain what is there in the LHS. So kx square plus kx minus 3 equal to, we'll just multiply x into x is x square plus x, then minus 3x minus 3. Okay, simplifying the like terms, we get x square minus 2x minus 3. Okay, so comparing the LHS and the RHS, you can cancel x square and x square terms, minus 3 and minus 3 terms. So we are left with the coefficient of x term. So kx equal to minus 2x. So we get k equal to minus 2. So this is the value of k. Hope you all understood this. Let's go to the 19th question. Solve the following. 2 cos 3 theta equal to 1. Okay, so cos 3 theta equal to 1 by 2. We are just taking the 2 to RHS. So you all know cos 60 is equal to 1 by 2. Correct? So comparing these two equations, what do you get? 3 theta is equal to 60. Correct? Because it is 1 by 2, so the angle will be equal. So theta is equal to 60 by 3, which is 20. Yes, it's very simple. Okay, the OR question. Express cos A in terms of sin A. So what are the relations you know between cos A and sin A? Let's recollect and write it. Which is cos square A plus sin square A equal to 1. So we are taking the sin square A to the RHS now, which is cos square A will be equal to 1 minus sin square A. So taking the square root to the RHS, we get cos A equal to square root of 1 minus sin square A. So that's the answer. We have cos A in terms of sin A. Yes. Now we'll move to the next question. The 20th one. The radius of the wire is decreased to 1/5, and if the volume remains the same, then find the new length of the wire. Okay, see there is a wire. So what is the shape of the wire? It's a cylinder. Let's draw a cylinder. This is the first wire before the radius is decreased. Okay, we name this as R and the height as H. Both are small letters. So now they have told the radius is decreased to 1/5. So which means the new radius will be equal to R by 5. That is 1 by 5 into R, which is R by 5. So we'll draw the new diagram. So if it is reduced, what will be the figure look like? So the r will become very small and the length will become taller, longer. Do you know why? Because they have told the volume remains the same. So the height is increased. So we'll name this as capital H. So new height equal to capital H. They have told volume remains the same. So volume of old wire equal to volume of new wire. So we are going to use a formula of cylinder. What is the volume of cylinder formula? Pi r square h. So we are just substituting it. And for the new one, we are using the new radius and height values. R by 5 the whole square into capital H. So now cancelling out the common terms, you get r square. We'll cancel pi alone here. So r by 5 the whole square becomes r square by 25. Then again we cancel r square and r square. The question is find the new length of the wire. So that means we have to find the capital H. So we will have capital H on one side and we'll take 25 to the other side. So it becomes 25 into small h. So now the new height will be 25 times of the old height. This is a required answer. Hope you all understood this question. Thank you so much. We will see the remaining questions in the remaining videos. For now, thank you so much. Thanks for watching the video. Thank you.